to this video, which I've entitled my, in brackets, ultimate MikroTik failover solution. Now, this is very much my way of doing it. There are other ways of doing it. It's not the gold standard in any way. I'm not advocating that it's the best way, but I'm just hopefully give you an idea of how I do it, and hopefully it works for you as well. So before we get into the actual how I've configured it, let's just jump onto and have a quick look at what I'm trying to achieve. So here we have a cloud, which is our generic internet, and then we're going to have router 1 and router 2. This is going to be our ISP1 and ISP2. Now ISP1 is going to be a primary connection, and ISP2 is going to be our secondary or backup. This is very much primary backup. We're not doing any load balancing, we're not doing any SD-WAN or anything fancy like that. We literally just want to say is if this connection to our MikroTik over here, primary one, has no internet access, we want to use our secondary. Okay, so what we could do is we could monitor this interface here, but that would imply that this, also it would not imply, but this would mean that this has to go offline somehow. However, we could have multiple routers in the ISP's network. This one could go offline. This connection is still going to be up because here to here is okay, but we've lost internet access. We wouldn't know that, and we wouldn't know to fail over, because although we may have a default route for this one, it's going to have a different distance, so it's not going to use it until this one actually goes offline, which if we unplug that connection, it would automatically take over. Okay, so hopefully that makes sense. Let's just dial it out back up. Okay, so what we're going to do is we're going to use an internet facing reliable source, or something to ping, which we're going to use as, you'll be familiar with, is Google's DNS. So hopefully that doesn't go offline. And what we're going to do is we're going to actually test that this connection works, and we're going to do that by pinging out of this one here. We can ping all the way over here. So if anything along the way happens, so he's gone, it's going to then say, I can't ping out of here anymore, I'm going to use this way. Okay, so we're going to do that by a combination of a Netwatch scripts and a scheduler. Okay, and here we're going to have a PC connected, which we're going to test from. So in the event that, so this is going to send, using Netwatch, it's going to be pinging here constantly. If that fails, it's then going to run a script which is going to confirm it's offline, fail over to this network, but then also run a secondary script which is going to constantly be checking this one. And if it fails, it stays down, fails, until eventually it's back up, and then it's going to reverse the whole thing, and we're going to then ping out. We're going to be going out of WAN 1, ISP1, whatever you want to call it, until such event that happens again. Okay, hopefully that makes a bit some sense. Hopefully it'll make more sense once we jump into the configuration. So yeah, we'll go ahead and do that now. Okay, so let's get configuring. We've got as I mentioned, the MikroTik we will be using is a CHR, which I've got in on a VMware instance, and then I've got the PC that I'm on right now is plugged into it, or virtually plugged into. This is also a virtual machine that I'm on. We're going to basic setup. We have, let's go to addresses. I'll just show you. We've got user 1, which is what my LAN is, which is what this PC is connected through. And then I've got 2 WAN connections. One is provided via PPPoE, and the other one is a static connection. Both of these technically will eventually route the internet via the same way, but what this is going to demonstrate is if these could be from two separate providers, as I mentioned. I'm using PPPoE because it's probably can be a common a method for connecting to an ISP, just for a bit of variety. However, this could also be 4G, LTE, could be Starlink, could be a number of other, lower level connections as your backup. So normally, as I said before in the intro, you're going to have a primary, which is going to be your more expensive, more reliable connection, and then you're going to have a backup, which is often going to be probably more expensive to use, or it's going to be, lower speed, and it is a backup. We're not doing load balancing. We don't have two dedicated connections, which are the same speed, the same reliability. This is literally, you only want to use the second one if the first one goes down. And again, I already mentioned about the different challenges when it comes to how to check. So what we're going to do here is show you how I think best to, and this is my ultimate way of doing it. This is how I do it personally. I find this seems to work the best. I've tested it in various different scenarios. And in this example, we're going to start off by using static routes. But I will also touch on what you do if you're getting your default route dynamically. So that's the addresses. If we go to my routing table, you'll see I've got my primary one here, which is a static one because we're statically assigning our IP address on that interface. And then we have this dynamic one here, which is set as a distance of 2. Now this is dynamic. So if we go to interfaces, and then we look at the config here on the dial out section, it's got our default route, and then we've got a distance of 2, and I've just changed that to 2 just so it is the default. However, that's only, as I mentioned before, that will only ever become primary should anything happen to this, and the only way that something happened to this is pretty much if the interface goes down. But we could have a solid connection to this upstream router, but then that router could not have, a good connection to the internet, but we wouldn't ever fail over. We would just have problems with accessing the internet. So for this example, what I'm going to do is I'm going to change this one to be a static route. So I'm going to go into back into my interfaces. I'm going to go PPPoE. Oh, the other thing I should mention, this machine, I've got two NICs on it. This one is just has no gateway on it, so this is just so I can access it from the management network I'm on. So when I play around with the internet access, I'm not going to get kicked off or anything like that, because that's not ideal when you're trying to demonstrate something. So I'm just going to untick the add default route. So then when we go back to our routing table, as you can see, it's gone. So now I'm going to add another static one. I'm going to point it to that IP that it was given. So this is if you know that this is always going to be the IP. This is always going to be your upstream gateway. So some ISPs will always give you the same one. Use the same one. If you have a dynamic IP address from your ISP, then sorry, not a dynamic, a static one, then chances are you're always going to be using the same gateway. However, I will show you as part of when we get into the scripting, how you tackle the different scenarios. Again, distance is now, we're going to set to 2. Okay. And what we're going to do is we're going to comment, and we're going to call this one secondary. Now this is useful as part of the scripts. There we go. So now we're still routing primarily out of the first one, and then the secondary one is going to be, so it's blue because it's going to be our backup. If I was to disable this, there you go. So it goes black, and it's now our active one. There we go. Simple. Actually, we'll keep that window open because we will need to see when the routes change. We'll just put that over here. Right. So the first thing next we're going to do, it's just a brief overview. Oh, the other thing I should mention, I've got a in my file, I've got my two NAT rules, masquerade rules for both interfaces. Again, you could put both of these interfaces into an interface list and then just have that as the out interface list. But again, we won't go in that in this video because it's probably a bit too much. So we've got our route set up. So these two routes here, which I've already set up, as you can see, are both again pointing to those gateways. Identical distances. Now this is needed because we're going to be using Google's DNS, primary DNS, as our monitoring IP, which we're going to check whether the internet is down. This is when we fail over to our second route. So the primary, so we can keep testing the primary until it comes up. We need this one, these routes here, so it still knows how to get to Google based on its interface. So that will come clear a bit later. So these two are, just the gateways, /32 for quad 8, and then distance 1, 1. So we don't have different distances on this one. Okay. We're not using any separate VRFs. We're all in the same VRF. We're on the same routing table. So there's nothing fancy going on there. So the next one we're going to do is we're going to set up our scripts. So let's go system scripts. So if you're not familiar with MikroTik scripts, they're really useful. I highly recommend that you get to grips with them because you can do so much with them. Which is again another reason I'm an advocate for MikroTik. If there's something that it doesn't do, like it doesn't have the an out-of-the-box failover mechanism, you can build on yourself using scripts. It's a little bit convoluted sometimes and a bit trial and error, and you get there in the end. But it really depends. If you're a sort of person that enjoys doing that sort of stuff, then it's as I am, then you'll I think you'll love it too. So let's add two scripts. Just move that over here. Now we're gonna have what we're gonna call what I'm gonna call the internet check. So we'll just call that inet_check, and then the other one's gonna be inet_check backup. No, that's not how you spell backup. There we go. So these are I'm gonna copy and paste this script in, and then I'll explain in a bit more detail what it's doing. Now, I also personally, when using scripts, I tend to work on them in a notepad or whatever text editor choice you want, just because it can be a little finicky doing in here. Sometimes when you press the space bar, you see your cursor disappears, and I don't know about you, but that's just a bit annoying. So for both of them, our local, the IP that we're pinging is we set a local variable. Again, if you don't know about scripting, in general, or any sort of coding, if you've never done any Bash or Python or anything, I'd recommend you check that out. But if not, there's a link in the description to an article I've got on my website, which gives a brief overview of scripting, and any useful scripts I will put on there as well, just because it's nice to have. So again, so we're setting a variable called IP ping, and we're setting it to that. So we would change that if we wanted to ping a different IP address. And then this is where you set the local interface on each. So our primary for each one is going to be ether1. And now what this is doing, it's going to set this, it's going to run this command, and it's going to set the result into this variable here, ping IP. So it's going to ping, and it's going to ping this IP, 888, using the interface specified here, and it's going to ping it 10 times. Now, the reason for this is when I show you the Netwatch, which is the tool which is going to initiate all these scripts, is you can lose a ping, but you don't want it to necessarily fail over straight away. You could have some jitter on your line, but if you're going to be flip-flopping all the time, you're going to, cause all sorts of problems with outgoing traffic sessions and whatnot. So we like to make sure that if it fails 10 pings, then we know for sure, we can be pretty certain that there's a problem that it's worth failing over for. And then you can adjust this as a need. So this could be lower than this, it could be 2, it could be 5, whatever you like. And then with that result, if the ping is less than 10, so it puts that result into this variable, and this is less than, so say it's 9, anything less than 10, sorry, it will fail. So when it fails, it will log. So this log info will put a log in our logs up here to say that internet primary is down. And then what it's going to do is it's going to find the route which is called. So the comment is primary, which is why I commented before. Primary, secondary. It's going to find that route here. So that's why I use the comments, because it means that if this was to change, we're not looking for a specific route to a gateway or something like that. We can base it on that. So we can change this here, and it'll still always take this as being the primary one. And what it's going to do is it's going to set the distance to 3. So if you remember, we set this one to 2. So if we set this to 3, this one becomes a primary. What it doesn't mean is we're changing this to this will always stay 2. So we basically just change the primary from being basically a higher distance. If that makes sense. And the next thing it's going to do is we're going to then enable this scheduler. So we'll get onto these 2 bits in a second. I'll just show you the internet check backup. Again, it's going to be a very similar thing. It's going to ping the same thing. So this will be enabled by once this has when this will run when this is found that there's a failure. So in fact, yeah, let's jump on the scheduler so that makes so we can kind of do it in a line. So let's go to system scheduler. And what scheduler does, as you can imagine, it schedules tasks, it schedules scripts basically. So you can have it run a command, you can have it do various different commands. You can run a whole script in here if you wanted, but we're going to just have it to which give it a name first of all. Scheduler failed over. So this is assuming that it has failed, so then this will start running. We'll set the interval so every 10 seconds, and then the start time can be whenever, it doesn't matter. And then what we're going to do it on event. So every 10 seconds it's going to run our backup script. Okay, so this is only ever going to run every 10 seconds when this is failed, because what happens is it's going to enable this, because by default what we're going to do is disable. Yes, so you can see it's disabled. So schedule's disabled. This runs, finds it's failed over, enables the scheduler. The scheduler runs this script here, every 10 seconds. And what this is going to do is the same as this one, but this is going to check from WAN 1, which is Ether 1, and it's going to attempt to ping Google, which is why we've got this route here. And if it fails every 10 seconds, I've just got it to log. You can get rid of this because if it's down for a long time, you're going to get a lot of log messages. But basically, this will just show you what it's doing. So what internet primary is still down, and basically does nothing else. However, if it finds that Ether 1 is now back up, what it's going to do is log, saying the internet primary is back up. It's going to now change that primary route back to distance 1. It's going to disable this again because this would have been enabled, and then it's going to enable our Netwatch, which is now what we'll get into, which is the final piece of the puzzle. So there's a tool called Netwatch on here. Netwatch, there it is, which I've already got here. Now this can basically ping. So it's simple, just means it's going to ping. We can do a HTTPS or HTTP lookup, so it can check a website is up or down. It can do a DNS lookup, as well as ICMP or TCP connection. However, we're just going to do a simple ping. And we're going to every 10 seconds. It's going to attempt to ping Google, and this will use its routing table here. So this is going to use whatever the primary route is here, which is going to be this. So should this one not be able to ping this, up we have nothing set, but down it's going to then run this. Okay, when it gets a failure, it enables the scheduler, but it also then disables this because we don't want this to be pinging, because this will then be able to use the secondary route. Okay, so not that that's a problem, but we kind of want to just, keep things. I like to keep things, not just doing stuff for the sake of it. Okay, so hopefully that makes sense. So I'll just quick running through it again. So the Netwatch is running. Every 10 seconds it's going to be pinging Google using this primary route. This route fails. It logs that it's down. It changes this to be the primary route. Okay, it's going to enable this scheduler and it's going to disable this Netwatch. This scheduler is then going to run this script every 10 seconds, which will check if what was the primary is able to reach Google again. If it isn't, every 10 seconds it will just log still down, and if it then can ping it, it'll then set its back up. It's going to change this route back to being the primary. It's going to disable the scheduler again, and it's going to re-enable the Netwatch. Simple, right? Okay, so let's put all this into action. So we're going to OK that, OK these two. So this should be running. As you can see, status up. I'll just disable that, enable that, and say unknown. Event after 10 seconds up. There we go. Okay, so there's our scripts, our scheduler, our Netwatch. We will bring up our logs as well. Okay, ignore everything up until this event because this is just me testing it. Okay, so what I'm going to do now is on the upstream router, so this one here, which I have on a different screen, I'm just going to disable the upstream, so this basically this interface that it's trying to get to, so it's going to fail the ping. Okay, now this could be because I'm not disabling the interface of this, so it would still see this interface as being up despite the fact that it can't ping anything. So it will show interfaces as well, just to give you that, because I don't really think I'm just simplifying it too much, because I could go more technical and then further down the line before it hits the internet break the internet connection for it, but it makes no difference in this scenario because Ether1 will always remain registered, will always remain up. So I'll do that now. So let's stop that. So he still sees registered. Okay. Oh. Okay. Let's just fix that first. So you can see we're trying to run that script, but it's got problems with the permissions. Don't require any permissions. There we go. Okay, let's try that again. Okay, let's disable the upstream interface. So this route should stop soon. Just run that script. As you can see there, the time started. The date's a bit out of whack. There we go. Looks it in. That's down. Route was changed. See, that's gone blue. This has been disabled. This has been enabled, and it's already run this once. Okay, still down. So we give it another 10 seconds. That should say still down again. I want a bit longer than 10 seconds because 10 seconds when it runs that script, then it's got pinged 10 times. There we go, still down. Okay. I won't. Well, once I get it back up again, I'll show you it with a live ping from this machine as well to confirm that it's routing okay. So let's re-enable that again. So it's still down. So now what's going to happen is it should get a response from the second once it runs this again. So it runs this secondary one again. There we go. Internet's back up. The route has changed back. This has been re-enabled. This has been disabled. Okay, so that's all worked as planned. So now let's run a ping. Ping minus T. I'll go to a different IP address for fun. And what we will also do is have another one with a trace route. So when it fails over, we can confirm where we're going. So at the moment, as you can see, so we're going to this IP address here. So this is the gateway of the machine that I'm on, which is the MikroTik, and then it's going to onwards to the internet. And it's hosted along the way. It won't resolve ICMPs. There we go. Cool. Let's keep this running. Okay. So let's disable it again. So let's minimize these two and disabled. So we just wait for it to fail over. Let's keep our pings. Oh, we've lost a ping because this is where you could tweak the times if you wanted a quicker failover. There we go. So we lost about 4 packets there, which, if this is your home network, would probably not be noticeable. If you're on a video call or a VoIP call, we'd notice it. But if you were watching Netflix or something, chances are you wouldn't have any problems. So now we can go re-enable that one. Let's just go ahead and re-enable it. There we go. Watched the packet that time. So yes, this is not the snappiest of failovers, but to be honest, I think it works pretty well in my experience. I've had it before where I've failed over to my 4G connection, and I've been working from home, doing various tasks online, and I've not noticed. The only way I've noticed is because I've got alerts set that will tell me that I failed over, for me to then jump in and see if there's a problem. But other than that, it's not been noticeable. So hopefully this is clear. Okay, well, thanks for watching. I do hope that's been useful, if that makes sense. As I mentioned, there are lots of different variables with this, depending on the type of connections you got. I'll try and maybe do another video where I've got some of the different options. Use this one as the kind of basis for it, and then we can look into other options. If we had a dynamic interface, as I mentioned in the beginning, giving you a dynamic gateway, the problem would be that we don't have the ability to name it, so we can't use that comment feature. So there are other ways around this, but I didn't want to make this video too long and too in-depth. So this is kind of an overview of how I do it, but we'll try and maybe look at different networks, different types of networks. So we could have a 4G connection directly connected to the MikroTik. We could have a dynamic gateway from our ISP that may change. So we want to avoid having to have the whole failover fail because we've picked up a different gateway, if that makes sense. But anyway, please comment on this video. Please let me know if you've got if you've tried this before and you've not got it to work, if you've got a certain setup that you would like help with, or have never really had much success with getting this to work. If you've just written MikroTik off because of this reason, please let me know. I would like to win you around, if that makes sense. Or if you've got any other ideas, videos you'd like made, please comment, and I'll get to them whenever I can. I do have as I mentioned before, the website, which MikroTikmasters.com. Please check that out. There's lots of other tutorials on there. So basically, I'll put up whatever tutorials I think are useful. There will be a whole scripting library available of different scripts I've done, and eventually I'll get around to making videos of those as well. But again, if there's anything on there you think would be useful, you can either contact me via the comments or via the website. and let me know what you think or would like help with. But if not, please like, subscribe. It does mean a lot. Keeps me motivated. And if not, I'll see you on the next one. Cheers.